Welcome to today's tutorials, and our topic for today is differentiation of functions. Now, when differentiating functions, there are two methods we could use. We could either use the power rule or use from the first principle. Now, we'll be treating using the first principle and the power rule. Now, solving for the first principle, note that the differentiation of x is equal to the limit at change of x approaching 0 of f as a function of x plus dx minus f as a function of x all over dx. Now this, we are going to simplify this to make it easier for every one of us to be carried along. Now first of all, we will turn x to x plus dx. X tends to x plus dx. This means f as a function of x plus dx is equals to 3x plus dx squared minus 2x plus dx. We only substituted the value for x with x plus dx. From here, this will be equals to, expanding this from 3 times x plus dx times x plus dx. Our answer here will be 3x squared plus 6x dx plus dx squared. Using normal expansion, you use 3 to multiply this and use this to multiply this. Now having that, our answer will be this. Now from here, f as a function of x plus dx is equals to 3x squared plus 6x dx plus dx squared, then minus 2 times x gives us minus 2x, minus 2 times plus dx gives us minus 2 dx. Now let's check if there's any like term in this equation we have. Now we can't find any like term. We would carry this now to that formula. So the differentiation of the function of x is equals to the limit at which the change of x approaches 0. Then we have our f x plus dx to be this. We will now have 3x squared plus 6x dx plus dx squared minus 2x minus 2 dx. Sorry, let's rub this off to use this part of the board. Then we have minus f of x, and our f of x from the beginning of our question is 3x squared minus 2x. Therefore, this will be minus 3x squared minus 2x all over our change in x. From here, this is equal to the limit at x, change of x approaching 0 of 3x squared. This 3x squared, then we have a minus sign here. Using this minus sign to expand this bracket, we have minus times 3x squared, we have minus 3x squared. Now we get back to this, plus 6x dx plus dx squared from here minus 2x. Now remember, we have a minus sign here. Minus times minus 2x gives us plus 2x. Now we have our minus 2 dx. Now this is subtracted from this. This is subtracted from this. We have our divided by change in x. This will be equals to the limit at which the change in x approaches 0. We will now be 6x dx plus dx squared minus 2 dx. These are the terms we are left with on the numerator of this equation, divided by dx. This dx will be divided from each of these terms we have in our numerators. This will be equal to the limit at which the change in x approaches 0 will now be, the x will be cancelled from here, we'll divide here, we'll have 6x. The x will be divided from here, we would have dx plus dx. Dx will also be divided from here, we'll be left with minus 2. Now, remember our limit is at the change of x approaching 0. Now we would substitute 0 for our change of x. This would be equals to 6x plus 0. Our dx tends to 0 minus 2. Therefore, the differentiation of the function is equals to 6x minus 2. Now this is all about using the first principle to find the solution to this problem. Now let's go on to see how we can use our power rule to find out. Remember our power rule, if we have f as a function of x equals to ax raised to the power of n, this would be, the differentiation of that function would be n times ax raised to the power of n minus 1. Now if we are to find that function we have there, fx is equals to 3x squared minus 2x. Now we would use this formula to find the differentiation of each of these individual terms. We will take this, using this formula to find the differentiation. Now 3x squared, from our inverse, it will be, from the inverse of that function, it will be our power 2 times 3x to the power of 2 minus 1. This would be equals to 6x raised to the power of 1. Now for the minus 2x, we will say if we have minus 2x, differentiating this will give us, remember this x has an divisible power of 1. This 1 multiplies the whole equation to be 1 times minus 2x raised to the power of 1 minus 1. From here, this is equals to minus 2x raised to the power of 1 minus 1, which gives us 0. And anything raised to the power of 1 gives us 0. We will be talking about that in our class of our tutorials concerning logarithm and indices. Now, from this we have x to the power of 0 will give us 1. We have minus 2 times 1, which is equals to minus 2. Now we can substitute this value for the differentiation of these individual terms back to our question we have. Now the differentiation of that function, which is the inverse of the function of x, is equals to 6x minus 2. Now if you observe, using this power rule, we have been able to get the same answer with using our first principle. Now I would like to give you a question to try and post your answer on the comment section. Now if we have f as a function of x equals to 2 over x. Now you could use any of the best suitable method for you. You can either use the power rule or use the first principle. Now thank you for tuning into our channel today. Remember to like and subscribe. Thank you.